In this video, I'm going to explain the imaginary variable I, the imaginary number I. It's chapter 6, section 7, and this is page 19 of your notes packet. And I'm going to introduce the concept by talking about if you have x squared equals 1. We know that if we solve using the square root method, we would take the square root of x squared and get x. If I take the square root of 1, I get plus or minus 1. Well, if you want to solve x squared equals -1, when you take the square root, you're going to get x equals plus or minus the square root of -1. So we have, as mathematicians, come up with a name for that. So we're going to call that I for our imaginary number. Okay, so it's the square root of -1. So I equals the square root of -1. And I'm going to give you several definitions here. If you take the square root of -1 and multiply by the square root of -1, you're going to end up with, we said I, and if I multiply those together, I get I squared. And this is like squaring the square root of -1, so this equals -1. So I squared equals -1 by definition. Typically, you will take the square root of -1 and make it I. And typically, you're going to take I squared and make it -1. So we know I is I squared is -1 by definition. I cubed could be I squared times I. This is I cubed. So I squared times I. So if I squared is -1 and you're multiplying that by I, you're going to get -I. So that means I cubed equals -I. All right, and then I to the 4th could be written as I squared times I squared. So remember our properties of exponents. If you are multiplying with the same base, you add your exponents. So 2 plus 2 is 4, and we already defined I squared as -1. So you would do -1 times -1 and then get a product of 1. So that's actually super helpful for some very picky questions down here where you're trying to simplify with I, which is a question that you're not going to see a ton of, and practically speaking, there's not a ton of those questions. Usually we're going to be dealing with the square root of -1 and I squared in other settings with operations. But these first 5 examples, I want to be simplifying, and I want to capitalize on the fact that I know I to the 4th is 1. And if you think about it, I to the 5th, which I don't ask you for, that would be I to the 4th times I. So if you can look at your groups of I to the 4th, that's really, really helpful, because I to the 4th is I to the 4th is just 1. So you have 1 times I, so that's I. Okay, and then if you do I to the 6th, you would have I to the 4th times I squared. So it's going to be 1 times -1, or just -1. And then it keeps circling. Okay, so here I to the 5th is I to the 6th is -1, I to the 7th is going to be -I to the 8th is just 1. I hope I said that right. It's a lot of talking. All right, so let's do some of these simplifying questions. So number 1, I have I to the 21st. So this would be I to the 4th. And then how many groups of 4 do you have? You have 5 of them. So it's almost like you're trying to write this as a mixed number. So you have 5 groups of 4. So I to the 4th is going to get raised to the 5th power. Power to a power you would multiply. And then that 1 would be left over. So just I. So now this is 1 to the 5th times I. So this is just I. Okay, I to the 10th, you would do I to the 4th squared. So 10 fourths is 2 and 2 fourths. So this is going to be your 8, your group of 8. So 2 groups of 4. So this is 8, and then you have I squared. So that's going to be 1 times -1. So this is just -1. So what I would say is try 3, 4, and 5 right now. Pause the video. And then here are your answers to 3, 4, and 5 for you to go ahead and check. Pause the video again here if you would like. I'm going to go on to number 6 at the bottom. So for number 6, this key line here is really, really, really important. You must always take out the imaginary number first. So that means I want to take out the square root of -1 first. Hopefully you're good at simplifying radicals. Always you are looking for your largest perfect square factor. So 25 is a factor of 125, and then that's going to be times 5. So if you take 125, you can break that into 25 times 5. Here you would have a pair of 5s. Your pairs would go here. So the square root of 25 times your leftover factor of root 5. So this becomes 5i root 5. So the square root of -1 will be your I, the square root of 25 is the 5, and then the square root of 5 just comes along. Okay? For number 7, you have a negative in front. You have the square root of -1. And then 60 has a perfect square factor of 4. So this would be root 4 times root 15. Okay, and then the negative's going to stay. The square root of -1 is I, and the square root of 4 is 2. So you're going to have -2i times the square root of 15. In number 8, you're going to have I root 7 times I root 7, and then you're going to multiply that out. I times I is I squared. And then this is root 7 times root 7, which is the square root of 49. But remember, every time you're squaring a square root, you end up with the radicand, the number in the radical. So that would be 7. So you're going to get -1 times 7, or just -7. All right, let's go on to page 20. All right, and then we have some tips at the top. So you must always take out the imaginary number first. I've already mentioned that. A pure imaginary number is b takes the form b times I, where b is a non-zero real number. So it's just a coefficient times I. 1 is a coefficient, so I is an imaginary number, but you could have 2i, -2i, 1/2 I, -1/2 I. And then this is really important. Root square root of a times the square root of b equals square root of AB. So this is your product property. Does not hold true if both A and B are both negative. And that is because what I set up here, you always have to take out the imaginary number first. Okay. And then what I would say for these 3 examples that I'm going to do right now, it is very important that you pay attention to the operation. And number 9, it's a subtraction question. And number 10 is a multiplication. And number 11 is a division question. So you want to think about that. When you add and subtract radicals, you are looking for like radicals. So in number 9, I want to take out that imaginary number first. So I'm going to get 5i root 6 minus. Now, this is going to be the square root of -1. The square root of 4 is a factor of 24. And then I always like to say these questions have clues because when you're adding and subtracting radicals, they want to be combined. So the fact that this had a square root of -6 kind of said to me, oh, I'm probably going to have a root 6 over here. So kind of look for that. All right, and then I have my operative, so my subtraction sign. And then I have the square root of -1 and the square root of 4. So that's going to be 2i root 6. Now, this part here is like x. So what this really looks like is 5x minus 2x, where x is I root 6. Okay, I wouldn't write that all out, but I just want you to think of it that way. So you have 5 of something minus 2 of something. So this is going to equal 3i root 6. And that's your final answer for that question. Okay, so we are combining like terms. Combine like terms when adding and subtracting. Okay, and simplify first. Okay, for number 10, we want to really think about how you have to take out the imaginary number first and how the product property does not apply. You cannot make this a square root of 81 and make it 9. It's a really, really popular question to get wrong on a midterm exam. So you have to be very careful here. So this is going to be I root 3 times I root 27. Okay, now I can use the product property. So now I can do the square root of 3 times the square root of 27, and I can get the square root of 81. I times I is I squared. I could have done the I squared first and then the square root of 81 second. It doesn't matter, just because I'm just multiplying. All right, and now we know I squared is -1, and the square root of 81 is 9, so this equals -9. Okay, and then number 11 is the hardest question out of the group. Always take out your imaginary number first. So I have 4i times the square root of 18 over I times the square root of 12. There's more than one way that you can do this question. The first thing that I noticed right away is that the i's cancel. You might pay attention to the fact that this is going to be 9 times 2 and 4 times 3. Okay, so then I could get 4 square root of 9 is 3 times root 2. And in the denominator, the square root of 4 is 2, and I have 2 root 3. 4 times 3 is 12. 12 divided by 2 is 6. You also could say 4 divided by 2 is 2. So you're going to get 6 root 2 divided by the square root of 3. And you are not allowed to leave that as your simplified answer because you have a radical in the denominator. So you may recall rationalizing a denominator in the past. So we're going to multiply here, and I get 6. Root 2 times root 3 is root 6. Root 3 times root 3 is the square root of 9, which is 3. Square root of 9 is just 3. And then 6 divided by 3 is 2, so I get 2 root 6. Now, that said, this time when I did this question, I actually noticed that I would have this, the 18 and the 12. They're both divisible by 2. So if you wanted, you could have made that 9. No, they're both divisible by 6. Divide by 6. So then that would be 3 halves. And that would have been a little bit quicker because I would have had 4 root 3 over root 2. And I could have rationalized here, and I would have had 4 root 6 over 2. And then that would reduce to 2 root 6. So that's a totally different way that I could have gotten the same answer. This way, I think, is a little quicker. But there's more than one way you can get your answer in questions like this. All right, thanks for watching. I hope this helps. Bye.